Hello class, today we're going to actually start section 2. In this section we're going to cover units of measurement. So a lot of this stuff hopefully isn't new, but if you're struggling on anything, make sure that you ask me because some of this might be review, but some of it might also be new to you. This section opens up by saying, what is the forecast for tomorrow, hot or cold? Will the high temperature tomorrow be 28 degrees Celsius, which is very warm, or 28 degrees Fahrenheit, which is actually very cold? If you don't include units, you can't be sure. So right here, it says 30 degrees. Well, I don't have a unit, so I don't know if it's going to be hot. I don't know if it's going to be cold. Tomorrow it says 28. I don't know which is which. So this is why units are very, very important in science. So we use what's called the metric system. It's the standards of measurement used in science are those of the metric system. It was originally established in France in 1795, and it's very, very important because of its simplicity and ease to use. So what makes the metric system easy to use? I know for a fact that I asked this on your guys' pre-test for this year, and I will ask it on your test. So know that I'm going to ask this question. The reason that the metric system is so easy to use is because it's based on multiples of 10. And this allows us to convert between units easily because since it's in multiples of 10, all you have to worry about doing is moving the decimal. If you multiply by 10, you would move the decimal to the right. If you divide by 10, you would move the decimal to the left. So the International System of Units, abbreviated SI, is just a revised version of the metric system. So the SI was actually adopted by international agreement in 1960. And there are 7 SI-based units. So right now, here is a good table of our SI-based units. Hopefully you're familiar with the length. So usually if you're measuring the length and I ask for the SI unit, it is typically meter, symbolized by a lowercase m. Mass is also a quantity. Mass's base unit is weird because it actually has a prefix on it, but it is kilogram, pronounced by the symbol lowercase k, lowercase g. Please note that it's lowercase. Temperature, this was talked about in integrated science. The SI unit is Kelvin, and it's a capital K. Time, it's measured in seconds, and its symbol is S, or I will also accept SEC because that's what other textbooks also say. And then the amount of substance, known as the mole, abbreviated MOL. You actually will learn about this later on, and my advanced chem kids are doing it right now. And then the bottom two we don't use in chemistry, but luminous intensity, which is represented by candela, and electric current, which is ampere. Now, all of these base units are where all the other SI units that we get for measurement are derived. So derived means it comes from, or it's built from. So derived units, for example, are volume, density, and pressure. It means we took these base units and we combined them. So in other words, you could say combined base units. So let's actually take a look at them. So all measured quantities can be reported in SI units, but sometimes non-SI units are preferred for convenient or practical use. So know that as we go through this section, I might say the specific SI unit for volume, but please know that there are other non-SI units that are also used for volume that we're going to do. Now, with all of those base units, we can actually add prefixes. So prefix, if you know what pre means, it means comes before. So comes before the base unit. Common prefixes that you should be familiar with is kilo, centi, and milli. So these are common ones that we use in everyday life. Their symbols are K, C, and M. And these symbols come before our base unit. So if we say centigram, notice that our base unit is gram, our prefix is centi. So we use the symbol for centi, which is C, and the symbol for gram, which is G. So CG is centigram. If we do millisecond, again, our base unit is second, so S. Our prefix is milli, so we have to put MS, millisecond. Often people actually get confused with these conversions, so I want to make sure that you actually know it. So meaning, what does kilo actually mean? Well, kilo means it's 1,000 times larger than the unit it precedes. So it's 10 to the third. That means it takes 1,000 of those base units to make up a kilo. So for a kilogram, my base unit is gram, my prefix is kilo. It means it takes 1,000 of my base units, grams, to equal 1 kilogram. For example, centi. Centi is 100 times smaller than the unit precedes. So it means it's going to take 100 centigrams to even equal 1 gram, since centigram's smaller. And then for millisecond, it means it's going to take 1,000 milliseconds to equal 1 second, because milli is 1,000 times smaller. So be familiar with those conversions. Now let's go back and talk about all those base units and what they mean. So for the SI, the base unit for length that we talked about was meter. So all measurements in length can be expressed for meter. However, sometimes there's very, very long lengths and distances and very, very small. So sometimes we might use a prefix. For example, the prefix milli, remember, is illustrated by the symbol lowercase m, means 1 per 1,000th. So a millimeter is 1 over 1,000th of a meter, or 0.001 meters. So a hyphen, the length of this, measures about 1 millimeter. For longer distance, things that are bigger, it is actually more appropriate to use the prefix kilo. So kilo means 1,000. So 1 kilogram equals 1,000. 1 kilometer equals 1,000 meters. So remember, we talked about those prefixes. Make sure you understand them. So here is a good table to help illustrate length and what is an example of how long those are. So if I say kilometer, remember 1 kilometer equals 1,000 meters. And if I said this is about the length of 5 city blocks. If I said meter, it's the base unit, so it has no relationship. And the height of a doorknob from the floor is about a meter. Decimeter, it means it takes about 10 decimeters to equal 1 meter. This is about the diameter of an orange. And so on and so forth. Even if you get down here to micrometer, it's 10 to the 6, or 1,000,000 micrometers equals 1 meter. And this is actually about the diameter of a bacterial cell. Please notice that micro is this weird looking U though. Okay. The next one we're going to talk about is volume. So volume is actually a derived unit. It's defined as the space occupied by any sample of matter. So how much space does it take up? You can calculate the volume in any cubic or rectangular solid by taking length by its width by its height. So this is a derived unit because it's combined length, basically, times length, times length. So the unit for length is meters times meters times meters gets me meters cubed. So since the SI volume is the amount of space occupied in 1 meter along each edge, like we just showed in the previous slide, the volume for SI is meters cubed. However, just like we mentioned earlier, we don't measure all our volumes in meters cubed. Sometimes there's a more convenient unit of measurement to use that is non-SI, and a good one that we use in the United States is liter. So liter is actually something you're going to go to the store if you buy soda, 1 liter, 2 liters of soda. It's defined as the volume of a cube that is 10 centimeters along each edge. So 10 centimeters, 10 centimeters, 10 centimeters equals 1,000 centimeters cubed, and that equals 1 liter. If you guys ever get to advanced chem, you're going to learn that 1 centimeter cubed equals 1 milliliter. So the smaller non-SI unit for volume, if we're talking about liter, is milliliter, considering the prefix milli. So 1 milliliter is 1 of 1,000th of a liter. That means that it takes 1,000 milliliters to even equal 1 liter. And I said this on the other slide, but because 1 liter is defined as 1,000 centimeters cubed, 1 milliliter equals 1 centimeter cubed. It's the same volume. So this is a good conversion that we use when we get to advanced chem that I'm going to point out here and you're going to see. So the units milliliter and cubic centimeter are interchangeable. These pictures right here, they give you some idea of the sizes of the liter and a milliliter. So a milliliter right here is a very, very tiny amount. You have to do it in eyedroppers. Whereas a liter, in case you get like a liter of soda, is pretty decently big. Remember, it takes 1,000 milliliters, 1,000 of those to equal 1 liter. Now, there are many devices we use to measure liquid volumes. I've had you use graduated cylinders already and tell me how many milliliters there are. But you can also use pipettes, burettes, volumetric flasks, and syringes. Now, the volume of a substance will change with temperature. So a lot of times we say that it's at normal room temperature. So here are some relationships for volume. So if I said liter, that's about a quart of milk. If I said milliliter, that's about 20 drops of water, and it tells me it takes 1,000 milliliters to equal 1 liter. For cubic centimeters, here's the relationship. It's about a cube of sugar. And even a microliter, that's a crystal of table salt. The next one we're going to talk about is units of mass. So mass is the measure in comparison to the standard mass of 1 kilogram. Remember, 1 kilogram is our SI unit. It's really weird because it does have a prefix. So a kilogram was originally defined as the mass of 1 liter of liquid water at 4 degrees Celsius. And a cube of water at 4 degrees Celsius actually measures 10 centimeters on each edge. And that's why we get that weird, wonky, the volume of 1 liter and a mass of 1,000 grams or 1 kilogram. So a gram is actually defined as 1 over 1,000th of a kilogram, and it's the mass of 1 centimeter cubed of water at 4 degrees Celsius. No, I do not expect you to know that for your test. So here are some good relationships when we talk about mass. So if I said you had a kilogram, it's about the weight of a small textbook. If I said you had a gram of something, it's about the weight of a dollar bill. If I said you had a microgram of something, that's literally 1 particle of baking powder. And the last but not least, we're going to talk about weight because weight is often mistaken for mass. When I say weigh something, we usually give it in terms of grams or kilograms, but there's a difference. Weight is the force that measures the pull of mass by gravity. So the key word here is gravity. Weight is actually a force, if you remember from integrated science, and mass is actually a measure of how much matter you have. Another way that weight and mass are different is that weight can change with its location. If you were to move from Earth to the moon, you would become weightless. But you didn't change up the mass you have. So hopefully you remember that from integrated science. I thought we were last. We got one more. Units of energy. So the capacity to do work and produce heat is known as energy. This was covered in integrated science. So the SI unit for energy is joule, named after James Prescott Joule. And another common non-SI unit is actually called the calorie. This is actually pretty important. You've heard the word calorie before when you talk about foods. However, this calorie is a little bit different because it's a lowercase c, so I want you to point that out. 1 calorie is actually how much heat is needed to raise the temperature of 1 gram of water by 1 degree Celsius. However, we do have those SI units and non-SI units, so we have to know how to convert between the two. So if I said I had 1 joule of something, it's the same thing as saying I had 0.2390 calories. If I said I had 1 calorie of something, it's the same thing as saying 4.184 joules. Now I said, do please pay attention that this is a lowercase c, because it's not the same as the calories that we have in food. In fact, a kilojoule is 1,000 joules. A kilocalorie, which is a food calorie, is actually 1,000 little calories. So when I say this is 80 calories for my snack, I mean 80,000 actual scientific calories. So what is the SI unit for volume? The SI unit for volume is meters cubed. In fact, the non-SI unit is liter. So that's it for today. It's a lot of information. It's a lot of sorting through things. And a lot of people usually ask me, Miss Justine, what do I need to know for my test? So for your test, I would know the base units and labels. So I would know that length is in meters. The number 2 is the prefix. So I would understand that, hey, 1,000 grams equals 1 kilogram. And then the third thing I would know from this section is the difference between mass and weight. And last but not least, you do not have to know all their definitions. You do not. But hopefully you would know that calorie equals energy. If I said liter, hopefully you know that is going to equal a volume. So you don't have to know those specific definitions or those specific numbers. Just be familiar with those 4 things for your test. Okay. And if you have any questions, please let me know. Have a good day.